Your Majesty, Your Excellencies, dear friends, to be here celebrating this 100-year celebration of collaboration on trade and, of course, looking at least 100 years into the future. And what I will do is basically take a scientific witness of the longer-term perspective of what really is at stake, even though, of course, there's a lot at stake here in Paris. But what is really at stake, I think, is fair to say, if this can click working, is really... Yeah, it should be working.
Green one? No.
I'm pressing the green one. Probably just a bit delayed. Let me start then by saying that I think the panels here today, so this is basically the starting point. I think it's clear to recognize that the Paris conference here and the discussions on a transition to a decarbonized future is all about what came out in this panel about a global transformation to a new relationship between a predominantly and dominant world on a small and finite planet, and to maintain a stable and resilient future. Now, this is my focus here, to set this celebration in this context. But I think it's worth, just inspired by what we're talking about so far, that we have 5 elements that have changed the wind, which leaves us to a much more, from a scientist's perspective, constructive viewpoint of what can come out in Paris. The first is that the science is, if possible, more established than ever before. And the recognition on risk and the recognition that we need to decarbonize and stay under the planetary limit of 2 degrees Celsius, which essentially scientifically means decarbonizing the world economy by 2050 or soon thereafter, is increasingly understood. The second is the point that came out here by Steve, that is recognized through the technological and innovation advancements and scaling we're seeing on renewable energy systems, that this is no longer a sacrifice. It's rather a discussion of opportunity, of responsibility, of innovation and transformation. The third element is that business is on board. We've never ever, from a scientific community, seen such a clear voice from industry across sectors saying that we need a playing field, we need regulatory measures on the long term, and if we have that, we're willing to transform and can actually benefit from it. And finally, policy has awoken. There's no doubt that policy is really waking up to this challenge. 2015 is a super year for sustainable development, and it's remarkable to see the engagement of 150 heads of state in Paris. So clearly, there's a new approach as well, which is this bottom-up, leveling playing field, the developing and developed countries putting their pledges on the table, and we're seeing remarkable action. In fact, it's a breakthrough already. So you could argue that Paris will deliver. The question is, will it deliver aligned with science? So that's essentially the assessment of the entry to this deal in Paris, which will be challenging, but clearly has a new wind blowing on the challenging face of climate change. Now, it's good to remind us just where we are on the kind of climate scientific area. And the first thing, because this is about the economy and about transformation, just a reminder that we have 3 really integrating dynamics hitting at us at the same time. A world economy projected to grow 3 times by 2050, which is essentially positive for both business and for the world. We're going to see a majority of poor being basically transformed into a majority of people with an average purchasing power of an average European, which is a tremendous breakthrough for humanity. The second one is the population growth, that we're soon 9-10 billion co-citizens on Earth, all with the same right to development. And this is an inevitable commitment and an ethical responsibility. And the third, of course, is the lower graph here showing the IPCC trajectories of the need to decarbonize the future to have a reasonable chance to stay under 2 degrees. And the black line you see is that we're following the average pace towards a disastrous future of 4 degrees. This is the collision, and this is what the Paris talk really will discuss and has to deal with. You've seen this, of course, which is a scientific assessment of the drama that we enter in Paris. The temperature rise so far, you see the 2015 estimate in the end, which is really dramatic. 2015 is predicted to be the warmest year ever recorded. It is an El Niño year, but it's also the year when we reach 1 degree Celsius warming, where at least the majority of this is a contribution of anthropogenic climate change. We're actually hitting the ceiling of the warmest temperature ever on average on the planet since the last ice age. And secondly, the reminder that 90% of this heat caused by our emission of greenhouse gases are taken up in the oceans. And we know this with high predictability today. So this is a reminder that, in fact, the planet subsidizes our economy in a very, very significant way. 55% of our emission of greenhouse gases are taken up by land-based ecosystems and the oceans, and heat is taken up by the oceans. So it's absolutely clear that the science is settled on the challenge. Then we have, of course, the point of the constructive attitude among those who come to Paris to negotiate a climate agreement. And much of that comes out, I believe, from the very important breakthrough that occurred in New York just some weeks back at the General Assembly, when heads of state met again to talk about sustainable development and actually endorsed the most important breakthrough document ever when it comes to our relationship with the planet, namely the Sustainable Development Goals. These are 17 goals that for the first time stipulates a transformation to a new logic for business, for society, for equity and development, where people is to aspire extremely, extremely important development goals of eradicating poverty, eradicating hunger, reaching economic development, equity, education, health, etc., within planetary boundaries, within set boundaries for oceans, for fresh water, for ecosystems and climate, and sustainable consumption and production and agriculture. This is the first time we have this setup for humanity, and it really guides also the Paris discussions, because this shows that heads of state are well warmed up for the discussions on setting this course straight. And this week, these 2 weeks, is really about Goal 13, about setting that transformation. And why this is so incredibly important in the discussion today is that the regulatory framework we set based on science to assure a stable planet is so fundamentally important, because we're facing a remarkable innovation journey outlined by so many scholars and thinkers and many in the room here, showing that we're just at the verge of a new exponential innovation journey of a digital revolution, a nanotechnological revolution, a material revolution, a revolution in business models to circular economic models. In fact, that we are able to provide, as Peter Diamandis points out in his book abundance for everyone on the planet. Now, if we allow this to occur in an unsustainable way, we risk rebound effects that would actually accelerate ourselves into a very dangerous direction. But if we could regulate this within a safe operating space on Earth, we might actually have an accelerated transformation towards a sustainable future where we can all prosper and have good lives on a stable and resilient planet. So we're in just this juncture right now. Will we be able to tip the world towards sustainable development? Can we this week tip the world towards a logic of decarbonization, but building on competitiveness and building on long-term innovation? That's kind of the strand of optimism that comes into this discussion, and it's clearly guided by science. Science has actually just recently stepped up and launched what is called the Earth Statement, which is leading Earth system scientists really putting the 8 important elements that Paris needs to fulfill. And the number one you see here is we need to stay under the planetary limit of 2 degrees Celsius. It translates into a global carbon budget. We have no more than 900 trillion tons of carbon dioxide left to emit during our entire future on this planet. And that this translates, if you take 900 divided by the roughly 35, 40 we're emitting each year, it gives us another 26, 27 years in a fossil fuel-powered world economy. That's simply the fact. We go beyond 2 degrees and we risk tipping points that could accelerate ourselves in the wrong direction. This statement also states clearly the investment needs, adaptation needs, the need for technology and collaboration, but clearly 2 and the zero carbon by 2050 or slightly thereafter are the key messages from science. And this is also listened upon much, much more clearly from policymakers. Now then, what is then the diagnostic of why this is so important? Why is policy listening? Why is business listening to this recognition that we actually need a transformation, not an incremental change journey? I will argue that it's 3 recent scientific insights that actually have reached out to society. And the first one is on this graph. It is the recognition from empirical observations that humanity has actually entered, since the mid-1950s, what science now calls the Great Acceleration. And the Great Acceleration, as you see on these curves, is on the x-axis from the Industrial Revolution, when the UK started burning coal in the 1750s, all the way till today. And you see the pattern These graphs actually show from carbon dioxide to loss of biodiversity to nitrous oxide to ocean acidification, deforestation to loss of biodiversity. This same pattern. Up until the mid-1950s, we actually had, as humanity, very limited impact on the planetary scale. And then you see all the curves bend upwards and exponentially start rising as hockey sticks. But it's not only carbon dioxide. It's essentially any parameter that you value, that we value, for our welfare and our economic development. They look the same. So we enter the Great Acceleration in the mid-1950s, and up until the mid-1990s or early 1990s, the planet clearly shows from resilient science and scientific assessments an ability to buffer our disturbance. The planet has ample space to take our impacts. To put it simple, we're still a small world on a big planet where there's ample atmosphere to buffer our emission of greenhouse gases. There's enough ocean to take up acidification and heat. There's enough forest to be deforested. We have so much redundancy in the planet that we do not get any invoices back. We're subsidizing our GDP-based growth in a very successful way. In fact, it's incredibly successful. We go to 6-7 billion people with a welfare we've never seen before. But from the mid-1990s onwards, this is when we enter the Anthropocene, the geological epoch where we are the dominant force on the planet, and we will start to cross tipping points that actually gets costs back to us. This is when we get the accelerated melting on the Arctic ice. This is when we get really dramatic effects on coral reefs, overfishing, in fact, collapse of fisheries, the Baltic Sea collapses, etc. So this is the first insight. We're in the Anthropocene. We're now in a geological epoch where we dominate the planet. We go from a small world to a big planet to now being a big world on a small planet. And this is simply a recognition that we have to navigate in a new reality. This leads, by the way, to turbulence that we've all recognized. The tremendous, disastrous instabilities we're seeing in Syria and the Middle East affecting refugee fluxes and instabilities and even terror in Europe can no longer be decoupled from abrupt global environmental change. Dramatic rise in phosphorus prices, oil prices, degradation, and the worst ever observed drought in Syria has had connections also with the social instabilities seen in Syria, where 1.5 million people left rural areas in panic into urban areas just before the insurgents started in Syria. Similarly, we're seeing abrupt and surprising changes right as we speak in Southeast Asia. So we have an unsustainable chopping down of rainforests transforming into monoculture of palm oil in Indonesia and in Borneo. We all know of that. This has led to a larger vulnerability to forests related to global environmental change and climate change, leading to forest fires which create smog and health impacts in Singapore, which in turn has feedbacks back to the climate system by leading to greenhouse gas emissions equivalent this year of an estimated amount of 600 million tons, which is actually equivalent to the annual emissions from Germany. So you see how one effect, climate change, unsustainable ecosystem management, leads to a surprise, forest fires, which has health impacts, economic impacts, and feedbacks to the planet. This is the kind of negative vortex of social ecological change we do not want to see, neither when it comes to insecurity, nor when it comes to the planet's stability. The second insight is really on Earth resilience, that we now recognize that the planet has this ability to be our best friend, to buffer impacts up to a certain point, but then if you push slightly further, a threshold is crossed and abrupt and irreversible changes may occur. We now know that the resilience of the planet depends on maintaining biomes like this. This is Svalbard, this is the Arctic, this is a permanent white surface that reflects 90% of incoming heat and is a precondition to keep the planet in a stable state. So for any finance minister in any nation, we now can no longer defend only our nation states. We also need to be recognizant of the importance of the coral reefs, the rainforest, the permafrost in Siberia or Svalbard, because this kind of tendency, when the Arctic sea ice accelerated melts, has impacts on Inuit communities and polar bears. But look at the color change. Just the shift to a darker color shifts the whole reflectivity on the planet, which self-reinforces warming to a point that we could actually lose the stability of the planet. So we are really in a key situation when it comes to the dire currency point for humanity. This is, if anything, what keeps scientists awake at night. Now, we're seeing the impacts of this in surprising ways. Scientists show, surprisingly, for example, just less than a year back, that glaciers are irreversibly sliding into the Amund Sea in Antarctica because of the warming upwelling of ocean water that has been hiding for us for many, many years, and then coming up surface-wise and melting ice that is sliding into the ocean, which could actually mean that we are committed to another 1 meter sea level rise over the next century. We're seeing these surprise effects for the first time since the 1990s as part of losing this resilience. That's the second insight. Resilience really matters. The third and final insight is, are we leaving Eden's garden? Can we define the desired state for the planet? And science can actually do that today. The scientific insight has come to a point where we can today define the planetary state that can support humanity towards prosperity into the future. And it comes not surprisingly from ice core data. We have to look into the past of how the planet has been swinging in and out of glacial to interglacial periods. And this is, I think, the most pedagogic graph we have around. It's ice core data from Greenland. It's on the x-axis 100,000 years of our existence on planet Earth. It's a wonderful period because we've been modern humans on planet Earth for roughly this time. We've had essentially the same possibility, intellectually and physically, to develop modern societies as we know them. On the y-axis, you have temperature variability in degrees Celsius, which is a good proxy of how it was to live on this planet. And as you see already from the graph, it was a jumpy ride indeed for humanity. This is a glacial period, it's a cold period, and as you see, you have tremendous climatic variability over very short periods of time. In fact, temperatures could vary with 5 to 10 degrees Celsius over just a decade, to the point, in fact, that you see a cold point there 75,000 years back. This is a point with 4 degrees Celsius lower temperature globally. Sea levels are 70 meters lower than today, and fresh water is tied in the poles, and we have such a rough time that estimates now show we're down to 15,000 fertile adults left on Earth. We're essentially eradicated. We've come to a point where we're hiding in Ethiopian highlands. We have a little bit of biomass and fresh water left to us, and we're essentially gone from this surface, and which, by the way, tells us we're very close family, all of us, as citizens on this planet. And this is where we leave for Europe the second time and colonize Asia down to Papua New Guinea. We then come to the last ice age, which is this actual point right here. And then we enter this extraordinary stable state we've learned to call the Holocene. This is the last 12,000 years, which is so stable, I would even call it miraculously stable. It is a period, an interglacial, which has a maximum temperature variability of plus minus 1 degree Celsius. So this point in time, when we meet here in this room, we're hitting the ceiling of the maximum temperature that the planet has experienced since the last ice age. Now, the drama of the Holocene is the following. We barely enter the Holocene, which is so stable that rainy seasons establish themselves, every ecosystem we know establishes itself, and what do? We do the most important invention we know. We invent agriculture. We plant seeds, we domesticate animals, which allows us to differentiate our societies and evolve to the modern societies as we know it, and we become the modern world of today, where we are 3 billion people at the Great Acceleration. We're 7 today. We're committed to 10 billion people. And we know today that the reason we invented agriculture was simply the stability of the Holocene, which made it predictable, because rainy seasons were no risk to planting. Dry seasons were no risk to planting. And this is the most important message from science to humanity, that the Holocene is the only state of the planet we know that can support the modern world as we know it. Now, this is, I know, a very dramatic statement from science, but it's also incredibly helpful, because the Holocene then gives us a good reference point. We know the Holocene. In fact, we know the carbon cycle, the atmosphere, the fresh water. We know that everything that we really, really value of the Holocene is in place then, and we understand it. This is the Raja Ampat coral reef in Indonesia that establishes itself in the Holocene and delivers to 250 million people in the world, depending on these systems along the coast. The temperate forests outside of Sweden, a carbon sink of tremendous importance for the stability in the Holocene. The rainforest in Congo, which is fundamental to be able to keep ourselves in the Holocene. the Svalbard permanent ice, reflecting back, fundamentally functioning as cooling systems for the Holocene, and fundamentally important. And the Iguazu Falls and the freshwater, which is a live stream for the entire biosphere. These are the insights of what science can tell us today when it comes to the Holocene. And it really gives us a new tool for understanding why we're here in Paris. Now, this is the same graph as earlier, but you see it's the last 20,000 years. We leave the last ice age. It's minus 4 degrees Celsius when we're in the deepest cold. And we go up into the Holocene, and you see this remarkably stable period between plus minus 1 degree Celsius. You see where we're heading? This is where we're meeting in Paris, right there. We're on average moving towards 4 degrees Celsius. But if you look at what science tells us, then if you combine this insight, this window of our beautiful sweet spot for development with the risks we're facing. So this is the same graph. You see again, you have the Holocene right here. And here's the 2 degrees Celsius limit that we're discussing here in Paris. But look at the yellow lines, which is the latest science on the potential human-induced catastrophic tipping points that we would cause if we pass certain degrees, the certain temperature thresholds. And you see coral reefs are actually threatened below 2 degrees. That's why Kiribati's president and the other low-lying island state presidents are actually arguing for 1.5 degrees Celsius threshold, because we're going to see tremendous adaptation and costly impacts way before 2 degrees Celsius, according to the science. Arctic summer ice threatened at 2 degrees Celsius. Alpine glaciers the same. Look at Greenland, which hosts 7 meters sea level rise, is at risk of irreversibly melting at the range of 2 to 4 degrees Celsius, and so on and so forth. These are non-negotiable biophysical thresholds in the Earth system, and we simply have these warning signals that we cannot negotiate with associated to our trajectories in the future. This is why Paris is so important, the proactive challenge of steering away from these thresholds that could actually self-accelerate warming. So essentially, dear friends, the scientific message today, which falls into place just the last 5 to 10 years, is we're in the Anthropocene, catastrophic tipping points cannot be avoided, and Eden's Garden is our most beautiful sweet spot for human development. And that is why science has developed a completely new framework to guide human future on this planet Earth, which is basically saying that if we know what our desired state is, if we know that thresholds could be passed if we push parameters too far, can we then define the Earth system processes that would enable us in the modern world to prosper within the Holocene? And this is what led to the planetary boundary framework. And the point here is just to communicate with you what Steve was pointing out, that what science now shows is that we can in fact define the processes that enables us to have a good future. And it's not only climate, it includes biodiversity, fresh water, nitrogen and phosphorus. It includes land management. It includes aerosols and air pollution, and also chemicals. It includes these factors that also integrate biodiversity. Now, these 9 together are well established today after 6 years of very, very scrutinous science. We have quantified essentially all of them to provide a safe operating space. If you go beyond these numbers, you risk tipping points that could propel us out of the Holocene. And as you see, unfortunately, we're in the danger zone in yellow and even in a very dramatic zone in red for biodiversity, climate change, land use change, and interference with nitrogen and phosphorus. And the key scientific message is essentially this. On the climate side, the only way to have a good climate future under 2 degrees, we also need to stay safe on the other boundaries. Because if we lose the land, or if we lose the oceans, they will undermine the ability to have resilience and sustainability for the climate system. So it's like basically the Three Musketeers, one for all for one. So this is a new framework which has actually guided the Sustainable Development Goals in a very constructive way, and we're seeing a recognition both in business and policy of looking into a safe operating space and sustainability as an avenue to avoid risk and have a good future for humanity. And to close then, what does this mean for the economy in just one reflection? Well, this is where we come from when it comes to sustainable development. This is the Brundtland Commission, great contribution in 1992 of the 3 pillars for sustainable development. We all remember it. It's very respectful, important, the ecological, human, and economic sustainable development. But unfortunately, we have to recognize that this has failed. It's time to leave this paradigm. It basically led to what we could call a Mickey Mouse economy, where the economy has grown at the expense of human capital and natural capital. And we now need to transform in the Anthropocene, in the Holocene challenging period, into what we can call an economy, certainly evolving in development, that supports and provides societal aspirations and good lives and good lifestyles and aspirational development goals within planetary boundaries, within science-based, defined, safe operating space. And that this is what we're starting to see in the Sustainable Development Goals, and this is what we're seeing when we're discussing 2 degrees here in Paris. Because clearly Paris is about a transformation. And remember this, incremental change will not do it. This is the Potsdam Institute effort of just showing that if we bend the global emission curve by 2015, the blue curve, we actually need to follow a pace of 5% per year reduction of emissions and basically decarbonize this is a great by 2050 in the world to have a chance, a two-third chance to stay under 2 degrees Celsius. So we need to really have the eyes on this when it comes to what we accomplish here in Paris. And my concluding remark is therefore, yes, we have scientific support that we need to tip the world towards sustainable development. 2015 seems to be actually ending up in this constructive, positive development. Decarbonizing the world is critical to secure human prosperity on the Earth, and the Earth definition is a Holocene state. And regulating the world economy is key for sustainable transformation to human prosperity on Earth. So basically the discussion we've had here on carbon tax, regulations, and collective policy action can create the innovation space to be able to secure this transformation. But it won't be easy, even though it's absolutely necessary, and indeed increasing evidence showing it's possible. Thank you very much.